Yesterday we were looking, I'm recording now, we were looking at weight calculations. Now, there's a few of these examples that we did. The weight or the concentration is given as the weight of the active ingredient divided by the weight of the entire mixture or solution times by 100. So there's actually a few examples here. I won't go over all of them, but the idea is like example 15 would be a good one to look at. This is kind of like a two-part question. It mentions or it asks you to calculate the concentration in volume and weight and weight. So we would call this, volume percent and weight percent. So for the volume percent, we have 30 milliliters of sulfuric acid, and we're dissolving it in 100 milliliters of water. So this we did yesterday, pretty straightforward calculation. I'm going to take my active ingredient, my sulfuric acid, 30 milliliters, and I'm going to divide it by the entire volume of the solution. The solution, the mixture, is the total amount. So I'm mixing 30 milliliters of sulfuric acid with 100 milliliters of water. So that gives me 130 milliliters total. Total. So I divide 30 by 130 and I get 23.1%. Now, to calculate this using the weights, we need a little bit more information. We need to do a calculation. I don't know the weight of anything. I certainly know the weight of water, but I need to know the weight of the sulfuric acid, for example. So how do I find the weight of sulfuric acid? Well, I use my formula sheet and I use equation. This is the formula sheet that is given on D2L, and you guys had it for your test last week. I use equation number 7 here to find the weight of the H2SO4. The weight of the H2SO4, let me zoom in, is the weight of the equivalent volume of water. So we're looking at 30 milliliters of water, which is 30 grams of water. And again, the beauty of water is that the weight and the milliliters will be the same. 30 milliliters, 30 grams. 1,000 milliliters, 1,000 grams. Or actually, 1,000 milliliters is a liter, which is a kilogram, or 1,000 grams. Anyways, I take that weight, which is 30 grams, and I multiply it by the specific gravity of that chemical. Now, the specific gravity is a number that will be given to you. You don't have to memorize them, obviously. There's actually like nothing you need to memorize. The formulas and specific gravities will be given. So the specific gravity which will be given to you is 1.84. So 30 times 1.84 means that the weight of the H2SO4 is 55 grams. So I do exactly what I did before. I take the weight of, I do exactly what I did before, but I use weights instead of volume. So the weight of the active ingredient is 55. I add that to the 100 grams of water to get my mixture and then divide. So let's look at some of these together. I asked you guys at the beginning of class to try these examples, but let's look at example number 16. Now, example number 16 is kind of like the warm-up question, very easy. We don't need to worry about specific gravity. All right, so let's look at this one. Just hold on one second. Okay, how many grams of a drug substance should be added to 240 milliliters of water? Okay, so read that carefully to make a 4% solution. Now, we are adding this to water. that means that this amount, this 240 milliliters, is not my total solution. This is what we would call the solute, or sorry, solvent. We're adding it to the solvent, and I need to figure out how many grams of the substance I'm going to add. Ooh, this is a tough one, actually. Now, I thought this was a straightforward one. This one's actually a little tough. Okay, so my formula is the percent of my solution is the weight of my substance, right? Over, so the weight of the solute over the weight of the solution times 100%. But there's a little bit of work here because I don't know the weight of the solution, so I'm going to need to do a little bit of work. So 4% is equal to X, that's what I'm looking for, over X plus 240 grams, that's grams. I'm going to leave the G out, but one thing I'll mention is that, of course, 240 milliliters of water is equal to 240 grams, and then times, of course, 100. So I end up getting 0.00, sorry, that's too many zeros, 0.04 equals X over X plus 240. This one is a little bit more challenging. Okay, so I need to solve for X. Well, first things first, I'll move this guy up here. So I will get 0.04 times X plus 240 equals X. All right, I'll get out my calculator because I certainly don't know what 0.04 times 240 is, but I do know that I'll get 0.04x plus, all right, so 240 times this number gives me 9.6 equals X. And now, guys, I'm just solving for X. So what I'm going to get here is, I'll do it this way. So 9.6 equals X minus 0.04X. So 9.6 equals 0.96X. Whew. So divide this out, divide both sides by that number. I'm going a little slow through the math here. Hopefully you guys are comfortable with the math. Oh, sorry, and this should be on the bottom. You divide both sides by the same number. So this should be decimal 96. All right, so 9.6 divided by decimal 96 would give me 10. Nice. 10 grams. So I'm going to add 10 grams to this solution to make a 4% solution. Pretty good, or a pretty easy number, a pretty nice number, not easy, but nice number. So there you go. I'll obviously do some more. If you're still confused, don't worry. So let's look at number 17, is it? Yeah, let's look at example number 17. Okay, if 1,500 grams of solution contains 75 grams, oh, this is a good one, of a drug substance, what is the percent? So this one's nice. This one's a nice and easy one. So here I have my solvent or solute. 1,500 grams would be my solution. This is a nice one. This one is one that you guys should really recognize. Ooh, okay, I'm getting some answers there. So I want to find my percent of weight. I'm going to take 75 grams divided by 1,500 grams. And a few students in the chat, I think, just said 5%. So let's see. 75 divided by 1500 gives me 5% exactly. That's a nice one. That one's pretty good, right? This one above, I don't know if whoever made this book wanted example number 16 to be this challenging. Again, it's challenging because we don't know the weight of the solution. But this one, number 17, is nice and easy. All right, let's do another one. How many, maybe I can zoom out and let you guys see this one. How many grams of phenol should be used to prepare 240 grams? Again, another easy one. 240 grams of a 5% solution. Now, this is the mass of the solution. We already know the mass of the solution. So I see somebody in the chat is writing and is probably with the answer. I hope, maybe not. But 5% is going to equal the mass of the phenol over 240 grams. And then, of course, we multiply that by 100%. So 0.05 equals x over 240. X equals 0.05 times 240. All right, let's see. 12. Now let me check the chat because I'm getting some messages up there. Hopefully people are saying 12 grams. Cool. There you go. So thank you, Asma. 12 grams. Somebody just asked in the chat, how did I get the answer for number 16? I'm going to need another. You're going to have to ask me another question. Like what I mean is, what part of this number 16, which is a tough question. What part of number 16 did you find challenging? The last step. So the last step is up here, right? Over here. I'll erase that, of course. I had 9.6 equals x minus decimal 0.04x. So I subtracted these numbers and I get 0. So like 1x minus decimal 0.04x would give me 0.96x. And then I divided both sides by that number. So I divided both sides by 0.96 to get my answer in grams. This is a little messy here. Maybe that's where you got confused. Let me just erase the bottom. This is 0.96. So I divided both sides by, again, this is, just straight algebra. I'm dividing both sides by 0.96 to get my answer as 10. That, I don't know why, again, whoever made this book didn't really plan it very well, because example number 16 is way harder than example 17 or 18. Okay. So let me do number 19. Then I'll ask you guys number 20, and then I'll kind of leave the rest for you guys to practice. There's a lot of practice here. Well, maybe I'll do another one later on. Yeah, maybe I'll do 27 as well. But let me, I don't know why 23 is giving you a full page. No, okay. I think it's just like whoever made the book just gave you a full page for 23. You don't need it. Anyways, let me do 19. I'll ask you to do 20, and then I'll do another one later. I think 27, I said, was a good one to practice. Okay, how many milliliters? Let me zoom in here. I'm an old man. I can't see that well. How many milliliters of nitric acid should be used to prepare 200 grams of a 5% solution in water? The specific gravity of nitric acid is 1.42. Okay, so a little bit of work to be done here. The first thing I'm going to do is figure out how many grams of nitric acid I need. Yeah, sorry, I'm just looking at my formulas here in my data book or my formula sheet. Yeah, so the first thing I'm going to do is figure out how many grams of nitric acid I need. Now, I know it's asking for milliliters, but I'm getting a weight calculation here. So 5% solution is going to equal the weight of my nitric acid, which I'm going to call X. And I'm also going to call nitric acid what it is, HNO3. Don't worry, you guys do not need to know chemical formulas here, but I'm just going to call it HNO3 so I don't have to write nitric acid. We're preparing 200 grams. Okay, so this will get me my weight of HNO3. Now, guys, I'm going to call that X. So what I'm going to do is I'm going to say 5% equals X over 200 times 100. So 0.05 equals X over 200. X will be 0.05 times 200. All right, let's see what I get. So I should know this in my head, but I'm tired. I just had a class at 7:30, so I'm just going to do my calculator, and I get 10 grams. Okay. Now, I have 10 grams of nitric acid. It's asking me for how many milliliters. So I'm going to use equation number 8 to solve this. Equation number 8 says that the volume of a liquid is equal to the volume of equal weight of water. I don't have enough room, so I'm just going to write volume of water, volume of equal water divided by the specific gravity. If any of you don't know where this formula is coming from, we did this last day, or we looked at this last day all the way up here on page 18. These formulas are on page 18. So I'm using this formula here. The volume of the liquid is the volume of the equal weight of water divided by the specific gravity of the liquid. Okay, so in your formula sheet, this is equation 7, this is equation 8. That's where the numbers 7 and 8 come from. That's what they are on your formula sheet. Okay, so let's scroll back down. All right, so equation 8, the volume of my liquid, which in this case is nitric acid, which again, don't worry, you do not have to know chemical formulas in this course. It's not chemistry. What is the volume of my equal weight of water? Well, I have 10 grams. So that means I'm going to have, this number here, guys, I'll just highlight it. Oh, I can't highlight it. Whoops. Never mind. Ignore that. Hold on, give me 1 second. I don't know why there's a box around that, but anyways, whoa, sorry, did not mean to do that either. There we go, no more box. Okay, so what I'm trying to say is this, there we go, is my volume. And the volume of equal weight of water is 10 milliliters. 10 grams of water would be 10 milliliters. So this would be 10 over my specific gravity, 1.42, and I'll get my answer finally. If you're wondering where 1.42 came from, it came from the question. So the specific gravity is right here. So 10 divided by 1.42, 7.04 milliliters. Phew. Okay. Cool. That looked like a lot of work. It actually wasn't. Or like it looks like I wrote a lot of information, and I know I did, but it's actually very quick. If you're not trying to explain it, it's not a lot of writing. And thank you for the answer there in the chat. That's perfect. All right. So why don't you guys take a minute and try number 20? And I'll be back. Just take 2 minutes for this one. And then I'll do number 27. And then we'll look at one little topic, and that's it for today. Okay, I won't go as long as I did yesterday. I know yesterday I went a little longer than I normally do. So we'll do this one. I'll show you number 27. We'll do one more topic and then halas. Oh yeah, and try number 20. Oh yeah. Sorry, I'm just reading the chat there. So people are sharing their answers, and then Kalsum said, "Oh, it's grams." And yeah, that's right. I didn't even notice that. This one's a little bit different than number 19. It's not the same. So for number 19, or sorry, for number 20, you might have to use equation number 7, which is the weight of the liquid is equal to the weight of equal water times the specific gravity. So that's kind of my bad. Like I didn't want to insinuate, is that the right word in English? I didn't want to imply, maybe that's the better word. I didn't want to imply that number 19 and number 20 were the same, but they are similar. So I'll give you guys another minute. I'm getting lots of comments and messages in the chat. I'm getting 27.6 grams. I'll give you guys one more minute to finish this one for anybody who didn't get or didn't know the formula here. And then we'll look at the answer. So just take one more minute. All right, let's have a look. Okay, I'm going to erase my writing here. Let's have a little look at this answer. Okay, how many grams of a drug substance are required to make 120 milliliters of a 20% solution? Okay, so step number one, I need to figure out, well, how, like it's asking for grams, but I need to figure out how many milliliters I need. So first things first, I think there's a mistake in this question, by the way. If I'm going to be picky with chemistry, I don't think this would actually work. But anyways, this is not chemistry. I won't get into details here, but I think you need to know the specific gravity of the substance. But anyways, that's for chemistry, not for math. So here we go. The 20% of my solution is going to make X amount of my drug substance over the entire amount of solution. So pretty straightforward setup for this. This is the solution. Very important that we know that. This is the entire solution. Okay, so 0.20 equals X over 120. X is 0.20 times 120. You guys do not need to show me all of your workings. Workings. So 0.2 times 120 would give me 24 milliliters. Okay, that's key. Now, if you're wondering, how did I know that was milliliters? It's because this is milliliters. So, sorry, what I mean is this up here is milliliters. The unit is based on what you enter in the question. So obviously, I'm not answering this question if it's asking for grams. So now I'm going to use my formula 7. Again, this number is from your data book or your formula sheet. I won't keep it there. Might be confusing for somebody who doesn't have their formula sheet. So the weight of the liquid is the weight of the equal volume of water this formula is too big, and I don't. Maybe I won't have to write it down every time, but anyways, and I'm multiplying it by specific gravity. Okay, that's all I'm going to write. So it's going to be 24 grams, and I'll explain where that comes from in a second. Multiplied by 1.15. Which is the sales tax in Canada, by the way, 15%. Well, the sales tax in my province in Canada, so where I'm from, this is how I calculate how much things cost, which I'm not looking forward to going back to this summer. In Qatar, there's no real tax. I mean, there's tax. Sorry, there is tax, but it's included in the price. But in Canada, they don't include the tax. So you go to the store and it says something is $24. Like say you buy a movie ticket. So you go to a movie, it's 24 Canadian dollars. But when you get to the cashier, like you pay your bill, it's $27.6 because of the 15% tax. Anyways, I won't get into it. I don't mind it. Taxes pay for public services, but it does suck sometimes to pay a little extra. Okay, so a couple things. Sorry. It's been a long morning, so I'm a bit silly. A couple things before I do this. Let me change my color. Whoops.
Mister,
Yes?
so I don't have to convert it to gram?
It is grams. It is converted. Right? Do you see the grams there? Hold on. I'm sorry. I'm just trying to get my pen working. There we go. I was having pen problems. So the question was, we don't have to convert it to grams, or do you have to convert it to grams? We did. This calculation on this side, the right side, is what's converting it to grams. The weight of the liquid, which is grams, is equal to the weight of the equal volume of water times the specific gravity. So it is grams. It has been converted. Um, keep in mind, like I want you to think about test number one. When you guys were doing test number one, um, some of you, like for example, and I won't do this today because I have a student writing the test this afternoon, but the last question on the test was probably the worst question in the sense that most people got it wrong. Well, no, not got it wrong, but most people didn't get full marks. And in that question, you had to think about grams and milliliters and gallons. Keep in mind that this milliliter here, there's no magic number in your data book or on your formula sheet to convert this to grams. And what I mean is, like, I know that I can change milliliters to, gallons or pints or ounces, yes. And then I could probably change it to pounds and then grams. But it depends on the weight of the liquid in this question. So there's no magic number in your data booklet or on your formula sheet to change this to grams. However, when I tell you the specific gravity, now you can do the conversion. And if you're wondering where the 24 grams comes from, this is because it's 24 grams of water would be the equivalent weight. Now, very important that you recognize that this would be water. And I multiply that by 1.15, which is my specific gravity, to finally find the grams. So again, sorry for going on the little rant there, but what I meant was, in this question, don't do unit one things. Don't try to convert ounces and liters and don't do that. Okay, it's different because every liquid has a different density, which means every liquid is going to weigh differently. So we can't use ounces and grams and gallons and pints and anything like that. We have to use specific gravity. Okay, let's do one more. And guys, we have so much time here. If you guys want me to slow down and do some, like maybe tomorrow, after you guys try a couple, you might want me to, at any time you could say, hey, Mr. Mark, could you go back and do question 25, 26? Absolutely. So anything I'm skipping here, I want you guys to try. And if there's a problem, if you get stuck or you're confused, just let me know. We have so much time. Okay, so example number 27. 50 milliliters of a liquid with this is a terribly worded question. So 50 milliliters of a liquid with a specific gravity of 0.9 is dissolved in this is a tough one, is dissolved in 240 milliliters of another liquid having a specific gravity of 1.25. Oh, this is a good one. So guys, this is so I'm not putting a star by this because it's important. Maybe I should do this. I'll put a sad face here. This is a tough one, but this is good for us to practice. So question A is actually quite simple. It's question B where we're going to have the problem. So I'm taking 50 milliliters of a liquid. I'm dissolving it in 250 milliliters of another liquid, and I need to find the percent concentration in volume and weight. The volume one, very easy. So percent as a volume, I'm just going to take my 50 milliliters and I'm going to divide it by the volume of the entire solution. Now remember, it's the solution. So you're not just going to put 250 here. You will need to add them together. So 50 milliliters plus, 250 milliliters times 100. Okay, so this ends up being 50 over 300 times 100. All right, So that's easy. If you got that on a test, that would be good, right? There's nothing too crazy about that. What I end up getting is 16.7%. It's actually 16.66666666 repeated on and on. I'll just say 16.7. Okay, so that one's pretty easy. What about B? B is a little challenging. Okay, so for B, if I want to find the percent concentration in terms of weight, I do need to find the weight of my solvent. I need to find my weight. I'm writing this small for a reason, of the solution. And I need to times that by 100. The problem is I don't know the weight of anything. So I'm going to use my weight formula, which is again on your formula sheet, the weight of a liquid. So I'll change my color here. Let's go blue. So the weight of a liquid is equal to the equivalent weight of water. So the I think the formula sheet says the weight of equal volume water times the specific gravity. Okay, so this becomes actually pretty easy. So my first liquid is going to be 50 grams. Now, where did the 50 come from? It's 50 milliliters. 50 milliliters of water is 50 grams of water. And I'm going to times that by 0.9. So this is my first solution. So 45. Oh, I should have been able to do that in my head. That's shameful. And then my second solution is 250 grams. So I'll pick another color. Let's go purple. So I also have a solution that's 250 grams. I'm going to multiply that by its specific gravity of 1.25. And I get 312.5. And now finally, I'm ready to solve this equation. So I'm going to scroll down. My two numbers are here. This is my solvent. Oh, sorry, I do that so much, even in chemistry. This is my solute, and this is my solvent. Remember, the solvent is the chemical typically in the bigger amount. The solute is the chemical in the smaller amount. All right, so finally, let's go back to red and I'll answer this question. My percent with weight is 45 grams over 45 grams plus 312.5 grams times 100. Whew, and that's it. It looks hard. Like, I don't know if it looks hard, but it looks like a lot of work. It is a bit of work, but basically we're doing a conversion. We're converting the milliliters to grams, and then I'm doing the same calculation. So let me do this on my calculator very quickly. And I end up getting 12.6%. Or 12.58. Now let's go 12.6%. Whew. The numbers are not the same, meaning what I mean is the number for question A is not the same as question B. And that's normal. The volume, or sorry, the percentage as a volume should not be the same as the percentage as a weight. So the fact that in one I have 12.6 and in another I have 16.7, that's normal. That's good. Okay. let's do, just give me like 10 minutes and you guys will be done for today. Let's do the last type. Basically, I'll do one. I'll do example maybe 29, and then maybe you guys can try example number 30, and that'll be it. All right. And then tomorrow we can do a little bit of review on this. We can practice some of this. There's a lot of examples here. And then there's mixed review. Definitely good to practice the mixed review because this will include questions from every section. And we're not going to do all of this. So tomorrow we will kind of skip ahead a little bit. Look at this. Tomorrow we'll do dilutions. That's exciting. I don't know if you guys remember dilutions from chemistry, but it is pretty cool. Okay, so 10 minutes, we'll be out of here. Let's look at this. What about if we mix them up? What I mean is, what if we calculate the percentage, but we want to use weight and volume? And this is very typical when you're dissolving a solid in a liquid. So again, I can give you the example of like dissolving, let's say 10 grams of sugar. That would be a lot of sugar. Let's say 5 grams of sugar into 1 cup of coffee. You would measure the sugar as a gram, as a weight, and you would measure the coffee as a volume. So you can mix these up. And normally, typically, it's not a good thing in math, chemistry, physics to mix your units, but it's okay in this situation. This is, again, like a recipe. So the formula for this, look at how it's written here. It's W over V, so it's W/V. What that means is it's the weight of the solute over the volume. So guys, what I'm writing in red here on the bottom, this explains to you what you're doing. The top one would be a volume over a volume. So the volume of the solute over the volume of solution. This one, what I'm circling now, would be the weight of the solute over the weight of the solution. And then this one would be the weight of the solute over the volume of solution. So, wink, 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 when I ask you one of these on a test, I will, in brackets, include this, what I'm circling up here. If it's VV, use all volumes. If it's WW, use all weights. If it's WV, use weight over volume. All right. We'll do some mixed review of this tomorrow anyways, but let's look at the example here. This expresses the number of grams in 100 milliliters of solutions. Of all the percentage strengths, we must be careful with the units. In the other ones, as long as the units were the same, we were okay. And what I mean by that is, as long as you're using gallons and gallons or liters and liters, everything is fine. For this one, we must have grams per milliliter. Grams per milliliter, very important. Not 100, but grams per milliliter. Okay, so a percentage strength, this is not really, I wouldn't memorize this example, but a percentage strength 12 means that we will have 12 grams over 100 milliliters. And you can check your answer here if you don't believe me. 12 divided by 100 is 12%. This, you don't memorize number 28, don't worry. Yeah, 12% solution would be 12 grams in 100 milliliters of water. Okay, so let's look at number 29. Convert a concentration of 20 milligrams per milliliter to 100. Oh, this is a pretty easy one. To grams per milliliter. Okay, well, so again, this is not really an example. I really wanted you guys to try something like 30, but anyways, I will do 29. I need to convert this to 20 milligrams per milliliter, per 100 milliliters. So first things first, let's change the 20 milligrams to grams. And you guys should be pros at this. You did it on your test. In 1 gram, there's 1,000 milligrams. So this would be 20,000. Am I doing that right? Yeah. Oh, no, sorry. Not 20,000. I am doing that wrong. This would be 0.0123 2 grams. All right, sorry. My brain isn't working after teaching at 7:30. I divide, of course. So this would be 0.02 grams. Okay. So its percent concentration as a weight and volume would be 0.020 grams over 100 milliliters times 100%. So divide that by 100 and then multiply it by 100, which doesn't seem like a good use of our time. But anyways, you will end up getting 0.02%. Okay, it asked us to convert it to grams over 100 milliliters. So I went from milligrams to grams, and then I divided it by 100 milliliters. Okay. So guys, it's 11 o'clock. I'm going to leave it here for today. Maybe tomorrow we'll do this one. But if you want, you can try it and I'll check your answer tomorrow. But yeah, you guys can give this one a try. It's pretty simple. You just take your mass, you divide it by your volume and times by 100%. But I'll leave it there for today. And then tomorrow we'll look at some more examples of this. And then I'll do a couple of mixed examples. And again, mixed examples means they could be from anything. You know, it could be weight and volume. It could be volume. We'll do a couple of those. And then we'll get into dilution. All right. So guys, that's it for me today. We had a nice short class. I think almost everybody's here, which is exciting. So yeah, thank you so much. Have a great day. And if there's any questions, let me know.